Let us look at question number 51, students. Consider the given working electrochemical cell. So we have been given a zinc anode and a copper cathode. The E0 values have been given to us. We can clearly see that the E0 of the cell will come out to be equal to 0.34 plus 0.77, which is equal to 1.11 volt. So we can also talk about the reaction which is going on inside this cell. So the zinc is losing 2 electrons and converting into zinc 2 plus. Whereas the copper 2 plus present in the system will accept 2 electrons and convert into copper. So the net reaction is zinc plus copper 2 plus, giving us zinc 2 plus plus Cu. So students, if we talk about the EMF of this cell, this EMF is generated by the forward shifting of this reaction. So with the passage of time, the copper 2 plus ion concentration is going to decrease, whereas the zinc 2 plus ion concentration is going to increase in the system. Let us look at the options which are given to us now. First option says with time the concentration of Cu2 plus increases. This is incorrect, students. If we talk about the second option now, with time the concentration of zinc 2 plus decreases. This is also incorrect. Copper 2 plus is consumed and zinc 2 plus is formed. So we can clearly see that the third statement is correct, which says that the concentration of Cu2 plus decreases, whereas the concentration of zinc 2 plus increases. And if we talk about the last statement, which is the fourth option, concentration of Cu2 plus and Zn2 plus remains constant always. This is also incorrect, students. Due to the forward shifting of the reaction, the concentration of copper 2 plus will decrease and the concentration of zinc 2 plus will increase. So third statement is correct, students, and we have to select the third option is the correct answer to this question. Let us look at the next question. Question number 52. For a reaction in which A is converting into products, the initial concentration of A is 1 molar and the rate constant given to us is 0.09 mole inverse liter second inverse. The rate of this reaction after 100 by 9 second of starting and 100 second of starting are X and Y units respectively. So we have to comment on the value of X by Y. So if we talk about the reaction which is given to us, we need to figure out the order first. So the order can be figured out by looking at the units of the rate constant K. So the rate constant K has units of liter per mole per second. So it must mean that the order is equal to 2. So the rate can be written as the rate constant into concentration of A raised to the power 2. So we have to comment on the rate of the reaction after 100 by 9 second and after 100 second. So for a second order reaction, we can have the expression as 1 by AT is equal to 1 by A0 plus KT. So the A0 value is given to us as 1 molar. So 1 by AT shall be equal to 1 plus 0.09 into 100 by 9 in the first case. So this will give us a value of 1 by AT equal to 2. So the AT value is going to be equal to half. So we can also find out the concentration after 100 seconds. So 1 by AT, so we can have T equal to 100 in this case. We had T equal to 100 by 9 in this case. So 1 plus 0.09 into 100, which on simplification will give us a value of 1 by AT equal to 1 plus 9, which is equal to 10. So we can have the concentration of AT, it shall be equal to 1 by 10. So students, we have to now comment on the rate after 100 by 9 seconds and after 100 seconds. So X is equal to K into half whole square, whereas Y is equal to K into 1 by 10 whole square. So we can have the value of X by Y equal to 100 upon 4, which is equal to 25. Okay. So students, for this question, we have to select the correct option as option 2. Let us look at the next question. Question number 53. An aqueous solution of urea is heated in a closed container at temperature T1 and the vapor pressure is found to be P1. If temperature is continuously increasing to T2, T3 and T4 and the vapor pressure measured at that temperature is P2, P3 and P4 respectively, so we have to select the correct order. It is given to us that T4 is less than the boiling point of the solution. So we know that as temperature increases, the value of vapor pressure also increases. So the correct order of pressure can be written as P1 less than P2, which is less than P3, finally which is less than P4. So this is the correct order of vapor pressure, students. And looking at the options, we can clearly see that we have to select the first option is the correct answer. Let us now look at the next question. Question number 54. An ionic solid is completely dissociated into ions in water. Sample of 9.6 gram of ionic solid is dissolved in water and the solution becomes 1 liter. The osmotic pressure at 27 degrees C for this solution is 60 R, where R is the universal gas constant. Assume that the density of the unit cell of ionic solid is 80 gram per centimeter cube and the anion form the lattice in which octahedral void at body center is vacant and the cell is electrically neutral. Select the correct statement about the structure of this ionic solid if H length of the lattice is 2 angstrom and the molar mass of the ionic solid is 96 gram per mole. We have been given the value of Avogadro's number. Okay. So students, in this question we have been given two information. First is the osmotic pressure data. And in the second case we have been given the density value. Okay. And it is also mentioned to us that in the lattice there is an octahedral void present at the body center. So it must mean that the anion forms a CCP lattice. Okay. Let us now try and solve for this osmotic pressure value which is given to us. The pi value is given by I into C into R into T. So I value is unknown to us. The concentration is 9.6 divided by the molar mass, which is 96. The volume is 1 liter given to us into R into T. 27 degree means 300 kelvins and the osmotic pressure is 60 into R. So in solving this expression we have the value of I equal to 2. So it means that the lattice is AB type. Okay. So there is one cation present for every anion in the lattice. Okay. Let us now try and solve the density value which is given to us. So we have density given by Z, which is the rank of the unit cell, into molar mass upon A cube into Na. Okay. So the density given to us is 80 gram per centimeter cube. Z value is unknown. Molar mass is 96. The density given to us is in gram per centimeter cube. So the A value has to be converted in centimeter as well. So A value is given to us as 2 angstrom, which is 2 into 10 to the power minus 8 centimeters. Okay. So this is 2 into 10 to the power minus 8 whole cube into Avogadro's number, which is 6 into 10 to the power 23. So the Z value comes out to be equal to 4. So as there are 4 anions in the system, we have to have 4 cations as well. So if you look at the options now, the first option says that the 100% octahedral voids are occupied. This is incorrect, students. The examiner has mentioned to us that the octahedral void at the body center is vacant. Okay. So the first option cannot be correct. If you look at the second option now, all tetrahedral voids are occupied by cation. This is also incorrect, students. For every anion forming the lattice, there are 2 tetrahedral voids. So 100% tetrahedral voids cannot be occupied. If you look at the third option, 50% of tetrahedral void is vacant. This is correct, students. For every n number of atoms forming a CCP lattice, there are 2n tetrahedral voids. So for electrical neutrality, the cation will be occupying only 50% of those tetrahedral voids, while the other 50% will be vacant. If you look at the fourth option now, 50% tetrahedral and 50% octahedral voids are occupied. This is also incorrect, students. Electrical neutrality has to be maintained, which is maintained by the cation occupying only 50% of the tetrahedral voids itself. Okay. For this question, students, we have to select the third option as the correct answer. Let us look at the next question. Question 55. Consider the following information about complexes. So we have been given a Mx plus, which is allowed to complex with chloride ions, cyanide ions and water. So it is given to us that the spin only magnetic moment of these complexes are 2.830 and 2.83 Bohr magneton respectively. Then the possible Mx plus is. So firstly, let us try and figure out the charge which is given to us. So we have MCl4 having a total charge of X negative. So we can have X, which was the charge on metal, minus 4, which is present on the 4 chloride ligands. It is equal to minus X, which on solving gives us a value of X is equal to 2. So we're talking about M2 plus. Now it is given to us that M2 plus forms a complex with Cl and Cn, and it has 2 unpaired electrons when complex with Cl minus, and it has 0 unpaired electrons when complex with Cn minus. It is also given to us that it has 2 electrons when it is complex with H2O, and it is an octahedral complex. So looking at this information, we can clearly see that M2 plus has to have a D8 configuration. Okay, so the D8 configuration is present in nickel. So nickel 0 is S2D8. So nickel 2 positive has to be S0D8. So students, for this question we have to select the correct option as option 3. Let us look at the next question.